So I'm Brendan Burns. I'm a software engineer at Google. I'm going to talk to you. I'm in the Google Cloud Platform. Before this, I worked on a search engine. We're hoping that one day it'll be as successful as Bing, but you know. All right. So, but in general, I work on the Google Cloud Platform, and what I've been doing lately is taking some of the infrastructure that is used to power Google Search and other Google properties that you may have used, and make it available to end users like you, whether it's in a startup, a non-startup, or whatever scale you're in. We're trying to take some of the infrastructure that allowed us to scale and build successful services and make it available to cloud developers. So I'm going to talk about that process, basically. All right, so for the last 15 years, we've actually been a cloud company. Whether you know it or not, we've been building, all of the people who build software inside of Google build software as if they're building against the cloud. And so I want to say, we launch 2 billion cloud jobs every single week. That's a lot of binaries going out, a lot of executables running. And I want to talk a little bit about how we've learned some insights from that and take it to the things we've learned and are making available to developers who are developing services in our cloud. So what have we learned? Well, I want to say there's 3 things that we've learned over the process of building these scalable applications. One is to hermetically seal your software. Your software needs to be something, so Avi was mentioning earlier, there's this problem of, hey, it works on my laptop, I deployed to production, what happened? You have to have an environment where that thing that you built is sealed up and ready to go and runs the same as it ran on your laptop as it will run in production. And containers and Docker and specific are things that we really see are pushing this trend. You need to decouple your systems. You need to be able to have individual pieces be able to scale up or down or be updated individually. I shouldn't have to block my front-end update because your back-end isn't ready to be updated. And you need to actively manage your infrastructure. Someone makes this akin to flying a stealth airplane. Most airplanes now don't fly by themselves. A human can't fly them. They need a computer in the loop, a controller to make sure that that thing stays stable, and software is no different. So I'm going to give some examples of this. And I wanted to say also that we have recently launched an open source project to take some of the initiatives and some of the paradigms that we've learned internally inside of Google and make it available to the world, whether you're running on our platform, your own hardware, someone else's public cloud. Come join us with this project. And it's going to make available to everyone some of these ideas that I'm going to go forward in the next slides. All right, so containers are really the thing that provide us with hermetic deployments. They're this lightweight Linux environment. They allow you to have an introspectable, runnable thingy. So it's a combination of a binary and a command line and all of the information that you need to run your program, packaged up in a way that you know that if it runs on your laptop, it'll run in the cloud. And Docker's been really the people who popularized this lately. Interestingly, it's based on a bunch of patches that we pushed into the Linux kernel in 2006. So that's really how you get to the hermetic deployment and solve in some ways, and this is exactly what Shippable is doing, solve it runs on my laptop, it will run in the cloud. And the next thing we want to do is we want to have decoupling. And fundamentally, decoupling means exactly what I said. If I'm an application developer working on the front end, I can roll a new update without having to worry about breaking my back end. How do we achieve this? Well, one thing we do is we provide logical compute. I worked for 5 years at Google, and I never thought about a physical machine once. I thought about, I have this binary that I need to run, I need 2 cores to run it on, go make it happen somewhere out there in the cloud. We provide this uniform compute substrate that essentially abstracts away the notion that there are individual machines. We run these hermetically sealed containers out on that substrate, and we've decoupled the people who are responsible for updating kernels, making sure our kernels are up to date and secure, making sure our operating system is up to date, from the people who are updating applications. That means those 2 processes can behave completely independently. I can update my operating system with good knowledge that I'm not going to break the application. I can update my application without having to worry about whether the security patches are there for my kernel. That's a really, really powerful freedom that you can have. And we also have a lot of decoupling. And this is an idea that we also think is becoming popular lately, the notion of a microservice, right? This is the services that glue your services together, a piece between your front end and your back end, such that if I want to scale my back end out, I don't have to re-update the config in my front end. I can take the front end, point it at an abstract service. That abstract service is responsible for naming and discovery and understanding what's running in the back end. So that's what decoupling allows you to do. And then finally, we want active management. This is something that is also in Kubernetes. It's the idea that every system that is out there has a desired state, a world that we want it to be, and a current state. And it's an active process of observing the current state, making changes to achieve the desired state. This happens all the time. If a job dies, So if I have a desired state that I want to have my front end and my back end running, but my current state is that I just have my front end running, I need to notice, I need to take that delta, and I need to create the back end. If the front end dies, I guess I don't get questions either. Likewise, with replication, I want to say something like, I have this front end, and I want 4 copies of it. It's an active state to say, hey, I want 4 copies, I have 3 copies, create a new one. Or I have 5 copies, maybe I had a network partition, I created one, and suddenly someone came back from that network partition, and I've got 5, I need to kill one. This also allows us to do auto-scaling really easily. This active controller that's responsible for taking current state, making it match with desired state. And of course, this runs on that decoupled uniform compute substrate. And so that's it, really. I want to say reach out to me. We are always hiring. I suppose I don't have the right badge, but we have an IRC channel, and we have the product up here on GitHub. It's called Kubernetes. Please come join us. Join in whether you're on the Google Cloud Platform already or whether you are interested in running it on your own hardware. And finally, just because everybody out there is in startup land and we're talking about funding, anybody out there, thanks for listening to me, and your prize essentially is $500 on the cloud platform, the Google Cloud Platform, to use for yourself. You can go to the Cloud Start Pack, try Kubernetes, and that's it. So, thanks.
One question.
Yeah. How does it scale down? Like, can you run it on your own personal cloud, something like that, 1, 2 clusters?
Sure, yeah, actually, so one of the interesting things that has happened with the sort of infrastructure as a service VM revolution is that suddenly a lot of the utilization inside of a data center doesn't apply to startups. And so we really designed this for people who are running 5, 10, 15 machines. So it really will scale down to, and I mean, we even have a version that runs locally on one machine, although I'm not sure why you necessarily want to do that, more for development than anything else. But we really aimed it at small scale usage, trying to provide some of the same concepts that allow for flexible deployment and different kinds of scaling, but make it applicable to people who are running things at a much smaller scale than what we originally designed them for out in Google.